Hello everyone. This video covers the lecture notes for week number 5. The main section covered here is section 3.3, which deals with quadratic functions. The four main things we're going to learn is how to complete a square. So this is a review from something that you've seen before. To write the quadratic function in something that's called standard form. Solve quadratic equations using the quadratic formula, find the maximum and minimum values, and finally model using quadratic functions. Now, just to refresh your memory from your past lives, so a quadratic equation, the graph usually looks like this, or it looks like this. So it has a maximum value here, and it has a minimum, which is related to what we did last week, the absolute relative maximum or relative minimum. But for a quadratic equation, you only have either a relative minimum or a relative maximum. And there are two ways to write a quadratic equation. You can either have f of x equals to ax squared plus bx plus c, or you can have f of x is equals to a times x minus h squared plus k. This is usually called a standard form, or at least that's how we will call it in this book. So if a is negative, you will have a maximum, and if a is positive, you will have a minimum. So the main your main task in this week or in this lecture notes is to figure out how to find minimum and maximums. If they give you a graph, it should be obvious which one is the minimum and which one is the maximum. But if you have an equation, then the main task is to figure out how to find these values. And to do that, you're gonna have to complete the square. And if you forgot how to do that, we will review it in a little bit. All right, so let's start with a modeling example. So here, this problem has to do with gas mileage. So the gas mileage for a specific car is given by this. So notice here the value for A in here is negative 1 over 128, which is negative. So that's why it's not surprising that this will have a maximum at some point. Okay. And here the domain is from 15 to 70, which means this equation or this model is only valid for this domain. So this is only true for the following values of the speed when you go between 15 to 70 miles per hour. So what this is telling you is that if you drive, let's say at 20 miles per hour, you will get around 14 miles per gallon. If you do 70, you will get like 4 miles per gallon and so forth. So clearly the maximum is somewhere here, which is passing 40. And you will see at the end of the video that the actual number is 42. So 42 will be the speed that will give you the best miles per gallon. Therefore, this will be the maximum miles per gallon. Now, before we go to the next example that is talking about standard form, so note, and this is very, very important, if the equation is on a standard form, which is this form, then the vertex or the coordinates for the vertex is going to be h, k. And the vertex is either the minimum or the maximum, depending on whether A is positive or if A is negative. So if A is positive, it will give you a minimum. If A is negative, it will give you a maximum. But if you have it in standard form, it's very easy to figure out the vertex. If it's not in a standard form, which will be something like this, then there is an equation to figure out the vertex. What you need to understand is that this and this are exactly the same thing. It's just a different way of rewriting the same equation. So I just mentioned this right now, but let me repeat it one more time. So if you have a standard form, it will be this, then the vertex will be the coordinates h, k, and this will open outward, or it will have a minimum if A is positive, and downward if A is negative. So in this particular case, the equation, which is not asking you about this, but this is a very good question for the quiz. What I will ask you was the equation of this graph. This will be A times h minus x minus 2 plus 1. So here the value for A we still haven't figured out, but clearly you can see that A has to be positive because the graph is going up. You can figure out easily what's the value for the vertex. So in this case, h is 2 and k is 1. So therefore this will be the standard equation, and it should be square. If you want to figure out what's the value for A, you need to use another point. Usually this is one of the best. This is the y-intercept, which is the point x equals to 0. In this case, y is 5. So if you use this value here, then you can find A, and we will do that in the coming examples. All right, so one last time before we move on, because we're gonna need this many times. If the equation is written like this is considered a standard form. The vertex will be hk. Notice how this is x minus h. And if A is positive, then the parabola will go up. If this is negative, it will go down. So negative means it has a maximum, and positive means it has some minimum. And the vertex will be h and k. And the vertex is the coordinate for the relative minimum or the relative maximum. Okay, now let's try an example where you have to change this into a standard form. And for that, you need to complete the square. And if you forgot to complete the square, well, this is your lucky day. You're going to learn how to do it. So this is what we have. This is the original problem. To complete the square, this is what you're going to do. You only focus on the first two terms, which in this case it will be this. Okay? And then you factor the number 2 in this case. So it will be 2 times x squared minus 6x. And then the 23, just put it in there. So just leave some space. So this is how you're going to complete the square. Whatever this number is, which in this case is minus 6, but whatever that is, you're going to divide by 2. Okay, so we have minus 6, and you always divide by 2. So you divide by 2, you get negative 3. Once you divide by 2, whatever you get, you square. So minus 3 squared is 9. And this is the number that you're going to add. Okay? So we put 9 here. And this is the part where you have to be very careful. So you are not really adding 9. You are adding 9 times 2. And 9 times 2 is 18. but the 18 was not here, so you have to subtract it. Because remember, you cannot change the equation. So if you add nothing, it will stay the same. So you have to add 18. So the key is this. So 2 times 9 is 18. And notice that 18 minus 18 is 0. And anything plus 0 is equals to 0. So this is one of the most famous tricks in math. Well, the point is that once you do that, this part now has to be a perfect square. So you factor, this will be x minus 3 squared. You should verify that. And then if you combine these two, which in this case is minus 18 plus 23, this gives you 5. And now this is in a standard form. So here the vertex is the coordinates, the coordinate of the vertex are going to be 3 and 5. Remember, if this is negative, this will be positive. If this is positive, this will be negative. Whatever is the same of this stays the same. So this is an equation form. Here the value for A is equals to 2, which is positive. So if we're going to do the graph for this one, it will look something like this. The vertex will be 3, 5. So let's say 5 is here, and then we'll go up like this. All right, the question is not asking you to graph it, but it will very soon. For now, it's just asking you to change it to standard form. So that's the first part, that's part A. For part B, it says to circle 1. So this one clearly has a minimum. You can see that's the relative minimum. Since A is equals to 2, which is positive, and clearly the graph opens upward, and determine the maximum or minimum value. Well, the minimum value clearly is this. So the minimum is y equals to 5. Okay, so the minimum is y equals to 5 when x is equals to 3. So this is just the coordinates for the vertex. Part C is asking you to find the x-intercept. And remember, x-intercept means that y is equals to 0. So y equals to 0, that implies that 0 should be equals to the equation we just have right now, which is 2 times x minus 3 squared plus 5. So if we try to solve for x, this will give us 2 times x minus 3 squared is equals to negative 5. Or x minus 3 squared is equals to minus 5 over 2. But remember that we cannot take square roots of negative numbers, so therefore this doesn't exist. So this implies no x-intercepts. Usually you will have 2, but in this case there is no x-intercept, and it will be clear when we do the graph. Now for the y-intercept means that x is equals to 0. So if you plug x equals to 0, this is the same thing as finding f of 0. So it will be 2 times 0 minus 3 squared plus 5. So this will be 2 times 9 plus 5, excuse me, which is equals to 18 plus 5, which is 23. So therefore the y-intercept will be the point x equals to 0 and y equals to 23. So now you have the x-intercept, the y-intercept, and the vertex. You can do the graph. Remember the vertex was 3, 3, 5. So this is the vertex. And the y-intercept is 0, 23, which is somewhere there. Now the vertex is also used to find something called the line of symmetry. This is called line of symmetry. And line of symmetry means exactly what it says. So the distance between here and here is 3. So if you move 3 to the other side, you will get the exact same coordinate. So it will be here. And then just do the graph. So the graph will look like this. And notice how there is no x-intercept, which means it never crosses the x-axis. And that makes sense in this case. So that's the graph. All right, well, if you didn't get this one, this is your lucky day. I'm gonna do another one, a different question, but it's exactly the same thing. So we did one where the vertex is the minimum. So we're gonna do now one where the vertex will be the maximum, which it will go like this. All right, so let's try this example. Again, this is very, very similar to the previous one. So the first thing is you need to complete the square to put it in a standard form. So this is what we have so far. F of x is minus x squared plus x plus 2. Remember that we only need the first 2. So we factor the minus 1, and this will be x squared minus x. And then this 2, just move it a little bit away. Right, then whatever this number is, which in this case is negative 1, you divide by 2. And it's better to leave it as a fraction. You can use a decimal too. So negative 1 over 2 is just negative 1 over 2. Whatever you have, you square, and that will give you 1/4. So therefore you will add 1/4. And in this case, if you add 1/4, because of this part, negative 1 times 4, you are technically subtracting 1/4. Remember, this was not here. So this is the key to the whole thing. So let me repeat this again. So minus 1 times 1/4 gives you minus 1/4. Minus 1/4 was not there. So you need to cancel that with adding plus 1/4. And therefore, from here you will have minus. If you factor this, it will be x minus 1/2 squared. This always has to be a perfect square. So the factoring should be easy. Actually, whatever you get when you divide by 2, which in this case is minus 1/2, you're going to get exactly that part there too. Okay? And then if you add these 2, that will give you 9/4. Okay? Remember 1/4 plus 2 over 1. The LCD is 4, so this will be 1 plus a, so that's 9/4. Okay. So you can see this is the equation now in standard form. Here the value for a is negative 1, which is negative. And the vertex will be 1/2, positive 1/2. And the value for k will be 9/4. Which means that when we do the graph now is going to go down. And this will have a maximum. So since this is the vertex, this is the maximum that it will get to. Alright, so therefore for part B, this says the function has a maximum since a is equals to negative 1, which is negative. The graph opens downwards and determine the maximum value. So the maximum value is y equals to 9/4 when x is equals to 1/2. Or you can just write the vertex is 1/2 9/4. Alright, so now let's find the x-intercepts. Remember the x-intercept means that y is equals to 0. Don't forget that y and f of x is the same thing. So therefore from this equation, from here, plugging here, we get this, that 0 is equals to minus x minus 1/2 squared plus 9/4. So if we move this to the side, we'll end up with x minus 1/2 squared is equals to 9/4. So therefore we take the square root on both sides. If you do that, on the left side you will have x minus 1/2, and on the right side you will have plus or minus 3 divided by 2, and finally x will be 1/2 plus or minus 3/2. From here you'll get two values. The first one is going to be 1/2 plus 3/2, which is 2. That will be the first value, and the second one, it will be 1/2 minus 3/2, which is minus 1. You should stop the video and check that. Right, next is the y-intercept. Remember, y-intercept means that x is equals to 0. So if we find f of 0, this will be minus 0 minus 1/4 to 1/2 square plus 9/4. So this will give you minus 1/4 plus 9/4, which is 8/4, which is 2. Now, to find the y-intercept is actually easier if you just look to the original equation. So notice that if you plug in x equals to 0, this disappears. The only thing left is 2. So I just did it a long way to show you that you should get the same answer. So therefore, the coordinates for the y-intercept is the point x equals to 0 and y is equals to 2. Okay. Right, the last thing you have to do is the graph. You should always start with the vertex. Remember, the vertex was 1/2, 9/4, and 9/4 is the same thing as 2 and 1/2. Sorry, 2 and 1/4. Remember, you multiply 2 times 4 is 8 plus 1 is 9. Or in decimal, this is 2.25. So the vertex is 1/2, 2.25, which is somewhere here. Then the x-intercepts is x equals to 2 and x equals to -1. So 2, -1. And the y-intercept was a 0.02. Remember that this is the line of symmetry. So therefore you need to have another point there. Then the graph will look like this, where you can clearly see that this is the relative maximum. All right, well, if you didn't get the first example and the second one, you have one more chance. So let's try this one more time. All right, so as usual, we start with the function f of x. In this case, is 5x squared minus 30x plus 49. Remember that we only focus on the first two. Factor whatever you can from these two. So in this case, this is just 5. Well, this is not really the GCF because the GCF is 5x. So you only factor the GCF with the numbers, not the variables. So then this will give you x squared minus 6x. Then close the parentheses and leave a space here and add the 49. So that's always the trick. Then again, in here, we have a minus 6. So whatever the value was, which is -6, remember you divide by 2, that gives you -3. Whatever you get, you square, that gives you 9. So you add 9 in here, but you're not really adding 9 because 5 times 9 is 45. So you add in 45, so you have to subtract 45. So that's why this will be minus 45. And then remember, this part will be a perfect square. It has to be a perfect square, so it will be x minus 3 squared. and this just gives you 4. So therefore, here the value for a is 5, which is positive. So that means that the graph is going to go up. Also means it has a minimum, and here the vertex will be the coordinates 3, 3, 4, and that will be the minimum value. So in this case, the function has a minimum since a equals to 5 is positive. The graph opens upward and determine the minimum or maximum. So in this case, the minimum value is y equals to 4, and it happens when x is equals to 3. Or in vertex form, this is just 3, 3, 4. All right, the next thing we want to find is the x-intercepts, which remember x-intercepts means that y is equals to 0. So we will have 5 times x minus 3 squared plus 4 equals to 0, because this is y or f of x. So therefore from here we have 5 minus 3x squared is equals to negative 4. But since this is negative, when you take the square root, is not part of the domain. So therefore this implies none. You don't have any x-intercepts. So all it means is that the graph doesn't cross the x-intercepts. It's still gonna go up, but it doesn't cross the x-axis. So this is one of the most fundamental principles for this class in calculus. So if this is negative, it just means it doesn't cross this line. Okay? But you always have a y-intercept. And the y-intercept, remember, that means that x is equals to 0. And this time I'm going to use the original equation. Remember, the original equation was this, plus 49. Clearly, here we find f of 0. Then this will give you 0 minus 0 plus 49, so is 49. So therefore, the y-intercept is the coordinates will be 0, 49. And that's how you find the coordinates. You can also use this, plug in x equals to 0. So you plug in 0, you will get minus 3. Minus 3 squared is 9. Times 5 is 45. Plus 4 is 49. But it's more work to find the y-intercept from here than it is from here. Now the last thing you have to do is the graph. And you should always start with the graph, with the vertex. Remember, the vertex was the point 3, 4. All right, for the last example, let's try to attempt to do this in general. So if you like this example, then you should definitely consider becoming a mathematician. If you don't like this example, you can always just become an engineer. So here it is. If we do this in general, remember that we start with these two only, and we move the c to the other side. And we're going to factor the a, because you want to leave the x squared by itself. So this will be x squared plus b over a, because when you multiply this times that, it gives you only b. It will be x. And then somewhere over here, put the c. Then whatever is on the middle, which is b over a, you're going to divide that by 2. This is the same thing as b over 2a. And remember, whatever you got, you need to square. So this will give you b squared over 4a squared. So therefore, you're going to add that here. But since this was not here, you also need to subtract the same thing. So now you have to subtract minus b squared over 4a. Then remember that this always factors to a perfect square. So this will be a times x plus b over 2a squared. And this will give you, if you find the LCD, will give you minus b squared plus 4ac divided by 4a. Okay, so this should give you this, and this part gives you this. Notice how the value for a doesn't change, so a stays the same. All right, therefore, if you compare this with the equation for a standard form, which is this, you should be able to see right away that this part represents the minus h, and clearly this should represent the k. So therefore, another way to figure out the vertex is this. The value for h is going to be minus b over 2a, and the value for k is going to be minus b squared plus 4ac divided by 4a. And if these values look familiar, it's because they are related to the quadratic formula. That's actually how you get a quadratic formula, is by comparing the square. All right, let's compare this with the previous method, and it's technically up to you which one you want to use, except when it asks you to change it to standard form. Well, you had to change it to standard form, but if it doesn't ask you for that, if it only asks you to find the vertex, then you can do it either way. So this is what I mean. Let's say that we have this example, f of x is equals to x squared plus 10x plus 22. So the old way to do this, which was the previous 4 examples, remember you factor, in this case there is not much to factor because there's nothing in front of the x. So you can just put a 1, it will be x squared plus 10x. You move the 22. Now 10 divided by 2 is 5. 5 squared is 25. So you add 25 here, but you have to subtract it here. So then this will give you x plus 5 squared minus 3. So therefore the vertex will be negative 5, negative 3. So this was the old-fashioned way. Here the value for a is equals to 1. Now the new way, so this is the old, which remember is the standard form. So in the new one, you have f of x is equals to x squared plus 10x plus 22. Here the value for a is 1, the value for b is 10, and the value for c is 22. So therefore the h value, or the x coordinate of the vertex, is going to be minus b over 2a, which would be minus 10 over 2, which is negative 5. And notice that's exactly the same value as here. And then the h coordinate, you're going to plug it in this formula. So this will be minus b squared, that will be minus 100, plus 4 times A times C divided by 4 times A. So this will be minus 100 plus 80A over 4, or minus 12 over 4, which is negative 3. And that's exactly the same thing we got here. So if I only ask you to find the vertex, you can do it this way or this way. It depends on you. If the question is asked in this form, this method is actually faster because it doesn't require for you to complete the square. But if the question is asked in a standard form, then this is definitely the easiest and fastest way to do it. So it depends on how the question is asked. All right, so just to recap, and this is what we just did in this past two new and old examples. The vertex will be minus b over 2a, or minus b squared plus 4ac over 4a. And the maximum or minimum occurs when x is equals to minus b over 2a. And the maximum or minimum value of b will be minus b squared plus 4ac, everything divided by 4a. All right, so finally, let's go to the first example we did. In this case, the value for a is minus 1 over 20a. The value for b is 3, and the value for c is minus 31. Now, since a is negative, remember that means that the graph is going to go down, and if it goes down, that means that it has a maximum, which we already knew them. What speed yields the best? So this is talking about the vertex. So remember, the coordinate for the vertex will be equals to minus b over 2a, which in this case will be minus 3 over 2 times minus 1 over 20a. And once you simplify all of this, and you should check this for yourself, this is equals to 42. Now, to find the actual maximum or relative maximum, so remember this will be the maximum miles per gallon, just plug it into this formula right here. So it will be minus b, so b is equals to 3, so this is minus 3 squared, plus 4a, remember a is minus 1 over 20a, c, which is minus 31, and everything divided by 4a. And this looks messy, but you can just use a calculator, and you should check that this is 32 miles. So therefore, the maximum miles per gallon you can get is 32 miles per gallon when the speed is 42 miles per hour. So therefore, the best will be 32 miles per gallon when the speed is 42 miles per hour. And that's it.